Okay, it is time to start officially. I suspect we're still going to be getting a few people coming in late, but please, if you have not taken the poll already, please take the poll. I'd like to know if you've seen some of the other Coroutine talks in this conference. And the other thing I want to say is that I'd like to try and make this interactive. We had somebody raise their hand. I didn't hear him say anything. I don't know if it was a mistake or not, but let's maybe try to do that. I think if you raise your hands, I should be able to see it. Of course, you're also welcome to type questions into the Q&A window, and I've got that up as well. And I'll try to answer those as we go along. So I like interactive talks. I like to be interrupted by questions. So please, if you have a question, feel free to raise your hand or type something into the Q&A. What I am not doing is I'm not monitoring the chat. So please feel free to talk about me in the chat. So without further ado, welcome to my talk. I'm Cheinan Marks. The title of the talk is From Problem to Coroutine, Reducing I/O Latency. This is something of a misnomer because in fact, my talk, as I developed the talk, things didn't work out the way I wanted them. And if you know my talks, if you've been to my talks before, this is one of their features. Typically, what happens is I try to do something, I have an idea, and hilarity ensues. So let's find out what my experience was with coroutines. Really, what I want to talk to you about is my experience with coroutines, the learnings I've had, and I see from the poll that many of you have not been to the previous talks on coroutines. In fact, that's the somewhat large majority. What I do want to emphasize is this is not an introduction to coroutines talk, okay? You don't need to be an expert on coroutines. You don't even need to have ever written a coroutine, but you should know the very basics at least. And I have some other talks here that I can recommend. In 2016, James McNellis gave a very nice talk at CppCon called Introduction to Coroutines. That's where I learned. Francesco Zoffoli gave a very nice talk on Monday about coroutines, and I am glad he did that. He goes into the details, and I would recommend you watch that talk if you want to get an idea about the details. What I'm going to talk about is more of what I learned and things to help you avoid pain in the future with coroutines. So I hope that is something interesting to you. And finally, if you just came late, please take the poll. I'm going to close that in 2 minutes, and I'm going to get started. I want to also mention Louis Baker's blogs, which got me started. They were written in 2017. And very, very detailed description of coroutines and how they work. And finally, the C++ standard itself. Coroutines are not a simple subject. And so I found that the C++ standard was actually quite a useful source for coroutine information. These were the sources I used for my talks with links. I didn't link to the CppCon talk, but you can find those on YouTube. At the bottom is my email address. Please feel free to contact me by email with any questions, and let's get started. So I had a very simple program to write. I work in bioinformatics, and I wanted to gather DNA reads from a FASTQ file, and I wanted to count the instances of k-mers in these DNA reads. And I swear this is the only biology slide in the whole talk. So this talk is not about biology, but we're going to get that out of the way quickly. FASTQ is a standard for storing DNA reads. These are the outputs generated by a DNA sequencer. And if you want to talk to me in the conference about DNA and bioinformatics and genetics, I'm all up for it. But we're not going to talk about it today. Essentially, what FASTQ is a ASCII file with 4-line records, that is, new line delimited records, and each record is a group of 4 lines. The second line is a DNA read, and this read is a string made out of the 4 bases A, C, G, and T, just like my t-shirt. Okay, N appears too. We won't talk about N. Anyway, it's ASCII. That's all you need to know. What is a k-mer? Well, you've probably heard of the word polymer. A polymer is the multiple repetition of a single molecule, like polyethylene, polystyrene, polypropylene. Our chromosomes are also polymers. They're multiple repetitions of the DNA bases. It's a little more complicated than that, but this is not the biochemistry talk, so we'll skip that, okay? A monomer is this polymer building block. So ethylene is the monomer for polyethylene. A dimer is a pair of monomers, and a kamer is an arbitrary number of monomers together. So K is this arbitrary integer, and kamer is an arbitrary number of monomers. And I give an example, AAT, GGGC is a kamer with length 7. So really, that was it for biology. Really what I'm doing is I am doing a substring search, okay? And so for example, if AT is my kamer and GATC is my read, I want to find all the instances of AT in my string, and here there are 2. Okay, so hopefully this is a very straightforward problem for us to understand. I purposely picked something very simple. In reality, I wanted to pick something that I really do for bioinformatics. I don't just count kamers, but that just complicated things, so I kept it simple for the purposes of this talk. But what we do is not much different than this. We do a lot of string manipulation in bioinformatics. Okay, so I had a very simple program to write, and here is my program. Okay, it's very simple. I open a stream, I loop on the stream, I ignore the first line because the second line is the one I'm interested in. I grab it, and then I pass that into a function that counts the kamers, and then I ignore the third and the fourth line, and I repeat until the stream runs out of data. And then I return the total number of kamer counts that I accumulated as I counted them as I read the stream. Okay, very simple, very straightforward, I hope, program. Okay, so then how did I count the kamers? Well, that's also very simple. I basically use string find to find the kamer, and then I got the position back, I advanced one, and I called find again. Now I know this is a terrible algorithm to do this sort of thing, and in fact, right, if the kamer is found many times in the read, this thing is going to totally bog down. It will become quadratic. So don't do this at home, but again, just for the purposes of illustration, this was good enough. And so I'm going to use this to illustrate my what I was doing. All right, so that's my program. Okay, and this program works, by the way. There's a little more extra stuff, but it works. And the beauty of using the simple program is that I can test it with grep. Okay, we have our first question. So please, let's try and see if you can talk. Go ahead, Bogado. You're muted. I cannot hear you at all.
Oh, no? Hello?
A little better, but I still barely hear you.
Hello?
Yeah, now I hear you. Okay, go ahead.
Okay, I'm leaning into the computer now. So if the kamer has the starting position somewhere at the end of the could it is that a valid find if the first kamer, the first the first substring that you're looking for matches also before it ends?
No, so the question, I'm not sure I got the question. The question was, is if the first matching kamer is at the end, is it valid? The kamer must be completely in the string. Are you suggesting there's a bug? I don't want to get into the details of this algorithm, please. If there's a bug. I just want to understand just okay. Yeah, yes. So the kamer must be completely there. Thank you, Bogado. Keith, you are raising your hand. Go ahead.
Hi, can you hear me all right?
I hear you great, yes. Hello? Oh, sorry, Keith. I muted you. Excuse me.
Okay. And so you don't want to focus on the actual algorithm here. You're going to...
Not at all. Not at all. I want to talk about coroutines.
Okay, great. Thank you.
All right. All right. So let's continue. And there we go. And forgive me, I'm getting the hang of this as we go along. So let's move on. but please do ask questions, okay? All right, so here's my simple program. It has two elements to it, okay? I'm gathering DNA reads from the FASTQ by reading lines from a file, extracting a portion of that record, and this is the I/O portion of the program. And then the second part is the compute portion, right? I'm counting the instances of K-mer, so I have I/O and I have compute, right? And this is what I wanted to accomplish. And in fact, I don't even need coroutines to this. This is something that I've done many, many times before. And this is, I've done this with the producer-consumer pattern using threads. I could sit in a loop on one thread, read the file, put the reads into a queue, and then a bunch of worker threads will pull the reads off of the queue and process them. This is boring. We've done this a zillion times. I'm not going to talk about that today. Instead, I had a great idea. And if you know me, when I say I had a great idea, it was not such a great idea. So let's use coroutines to reduce latency. I watched James McNallis's great talk from 2016 about how to use coroutines for asynchronous I/O. And I thought, well, gee, maybe I can do something to do that here, because I/O is one of the big problems in processing FASTQ records. FASTQ records can be absolutely massive, like gigabytes. Okay, so the idea I got, and of course, new features are always presented as that it's relatively simple, it's easy, if convoluted. There's a lot of details. You have to write a lot of boilerplate code. But the really cool part is that all you have to do basically is add the co-await to the asynchronous parts, and then magically you get this speed up in your program. You get practice with a new C++20 feature that looks really exciting. You're a hit at the C++ parties, and everything's great. And so the impression I got from watching these talks was something like this. Here is my program, right? Here's the I/O part on the first line, and then here's the compute part on the second line. I would do this, and magic would happen, and everything would run faster, and it would be great. Sure, I would have to do a little work, but that's what I was expecting, sort of. Well, let me tell you, it was nothing of the sort. Adding these two keywords, it sent me into a world of pain and hurt. It was hard. I basically had to learn what coroutines were all about and how they work. And I learned a whole bunch of things on the way. And let me just end the poll here. There we go. So most of you have not been to the previous talks, but let's go back. I learned a whole bunch of things along the way about coroutines, and that's what I want to share with you today. So I'm not going to go into the details of how coroutines work. I will show you how I wrote my coroutines, okay? But I will not gloss on the details, especially of the boilerplate. Instead, I want to share my aha moments in the coroutines, what helped me understand coroutines, and how to use them. So I hope that this is something that is going to be interesting to you, and I hope you stick with me because that's what the talk's all about. So I am going to spoil the talk by telling you what I learned, if I can get back to my talk, whoops, up front. The first thing that I really learned right away was consider not using coroutines. As I said, I went into a world of pain. And Louis Baker said this very nicely, okay? He said, the facilities, he wrote this in 2017, okay? So the facility, I'm gonna just read it. The facilities of the Coroutines TS, which is now the C++20 standard, okay, can be thought of low-level assembly language for coroutines. These facilities can be difficult to use directly in a safe way and are mainly intended to be used by library writers to build higher-level abstractions that application developers, that's me, and hopefully you, can work with safely. If you were at Eric Niebler's talk yesterday, Eric is a library writer, and he's at a different level than me. I'm an application developer. I'm very grateful that Eric works so hard to write these libraries so that I don't have to. And I literally was sent back in time to back when I was young, and you actually really had to do things in assembly language sometimes. and coroutines brought that all back. So this is a very true statement, and this is why I had all the pain, and that I want to share with you and share with you what I learned, because if you're going to do coroutines anyway, and I'm going to do coroutines anyway, I'm not giving up, okay? You're going to want to know these things too. Perhaps some of these are obvious to you. They were not obvious to me. So let's talk about these, okay? The next thing I learned was, if you can, wait for standard library support for coroutines in the next standard. Again, Eric Niebler talked about this very nicely yesterday. He talked about executors, which will be a tremendous addition to the standard library and make coroutines a much more usable thing in the context of what he calls structured concurrency. If you haven't seen his talk and are interested in the subject, please go see his talk. I know from bitter experience that you cannot wait for the committee to do things. It might be 26 until this comes out. I hope not, but we won't know until the actual vote happens sometime in 2023. If you can, consider using a coroutine library. I had reasons that I could not, but there are several good ones out there. Eric demonstrated the Unified Executor Library. I think it's from Facebook, the Unifex library. Folly, Facebook's framework, has a coroutine library, which I understand they use. I've had a lot of trouble trying to use Folly, and so I gave up on it. Maybe I'll try it again. Louis Baker had one. Anyway, by the time you see this online, my advice may be out of date, so I'm not going to advise you to use a specific library. Search for whatever the most current thing is. Now, if you're still with me and I haven't scared you away, once I learned all these things about coroutines, I really actually started enjoying them, and I realized what their power is. So if you're still with me, let's go in and see what actually happened with the coroutines. The first thing that I learned about coroutines is that you want to plan out the use of the coroutine itself. And the coroutine is the function that has the co-yield, the co-return, or the co-await keywords in them. That's the coroutine body. And that was my first aha moment in this process. And you may be saying, this is obvious, Cheinan. Why are you telling me this? Well, when you go and read all the details, and I was reading the details in the standard in Louis Baker's blog, you get so deep into the forest, into the details, you forget the forest for the trees. I was like, not only at a tree level, I was looking at a bug on a leaf with a microscope, okay? There were so many details that I forgot what it was all about. And then I got into the boilerplate, and I was playing with the boilerplate, and I was trying to get the coroutine to work, that I forgot what it was I was trying to do. So what I want to say is, first write the coroutine itself, and then add the boilerplate, and you will be much happier. Once I had that aha moment, and I switched from writing boilerplate first to coroutine first, things just fell into place. And that was my biggest aha moment. So let's talk about what my process was. I sat down and asked myself the question, what am I doing here? Where can I use coroutines in this process? And then the second problem was, should I use coroutines? And in fact, the second question is relevant, should I use coroutines? Because one of the places where I wanted to use coroutines was a bad place, and I got rid of it. So again, oops, sorry, went the wrong way. So what am I doing? I am reading I/O in unstructured records. By unstructured records, I mean the records have variable sizes. This is very unfortunate. And that means you cannot calculate the record location of future records. That is, to read record 1, you have to first read record 0, and then you can read record 1 and then record 2. And you can't calculate where record number 1,000 or 1,000,000 is. And that's very unfortunate, because it makes it a lot harder to do things asynchronously. The I/O has to be done sequentially, essentially. All right. And then the second thing I'm doing is I'm computing on the data that I received from the I/O. Okay, so these are the two tasks that my program is doing. And then the question is, where can I use coroutines to do these tasks? Okay, so I'm going to open the forum. I'm going to try this out to add suggestions. Does anybody have any ideas where I could use coroutines here? Let's see if this works. Please raise your hand or type into the QA. Okay, we have somebody. Let's see. Go ahead, Keith. You're muted.
Hi, can you hear me?
Now I hear you.
Well, the most obvious place where coroutines would be used is to load the data from disk, very time-intensive operation, and then have, maybe even several different threads if these files are so big. Not threads, sorry, different coroutines. So load the data in, make it available for processing in memory, which is going to be much faster.
Exactly. So that was exactly one of my idea was, I'm going to put you away, Keith. Thank you. I assume everybody hears him, but I'm going to repeat this for the record. And Keith said, well, the I/O is a slow process, so we can put it in the coroutine and possibly do it in multiple threads and use the coroutines to save time in that way. And I had that idea as well. So yes, absolutely. And we will talk about that. I will also say another place where I wanted to use a coroutine, and I'm going to start with that one because it's simpler, is to, oops, and I lost my focus here, is to offload the compute to a worker thread. And I will explain why I'm doing this one first, because the I/O turned out to be more complicated. So one thing I could do with the coroutine is, in addition to the I/O, I could offload the computation into a worker thread. And I see Robert also put a in the QA, which you all can see, and you're saying the same thing, basically, right? As Keith said. So thank you for that. I'm going to mark that as answered live and answered, I hope. So the first thing I'm going to show you is offloading the compute to a worker thread, because that's a much simpler thing to do. So you're right, we're going to read the I/O, and we're not going to talk about that yet. And let's pretend that we have the read string somewhere, and then we're going to do the compute. And we want to do that compute in the worker thread. And then that can, while the compute is going on, we're counting the k-mers, we can go ahead and read the next item in the coroutine, in the file, excuse me. Okay, so what I did was something like this. There we go. I co-await on resume in compute pool. Okay, so if I get the read magically, right? We're not going to talk about that. Somehow I get the read. I co-await and resume in compute pool, and then I actually do the computation of the k-mer count. Okay, and then when I'm done, I coroutine the k-mer counts. Okay, so this is how I would offload the computation in a coroutine, and this is showed by James McDonald in his talk, and that is a routine. That is a technique that I used here. And let's see, we have a comment from Dietmar Kühl. You don't have to, you can all read it. I won't read it for you. Right, and so Dietmar says that I can kick off multiple IOs on the IO thread and deal with them once ready. It turned out that this was a lot more complicated than, I'm going to answer that live. It turned out to be a lot more complicated than I thought at first. That was my idea as well. And that turned out to be not so easy. So I didn't do that, in fact. But let's talk about the compute for now, because that's why I'm starting with it, because the IO turned out to be problematic. So let's do this. So this brought me to the first realization about coroutines, all right? But let's talk about what's going on here. And this is the idea of transfer. And transfer is the idea that you can transfer a coroutine that starts on one thread, you can suspend it, and you can resume it on another thread. And this is cool. This is one of coroutine's superpowers. And the reason it's really cool, well, before we talk about why it's really cool, let me just say that there's two kinds of transfers. One is called asymmetric transfer, and you may have heard these terms thrown around. And that's where you either return to the caller and suspend, or you resume the coroutine immediately. And that's what I'm doing in my talk. There's also symmetric transfer, which is to resume onto a second coroutine, and you can chain them, okay? And that actually turns out to be a bit tricky, and I'm not going to go into this in this talk. That's a more advanced subject. So we have two questions in the Q&A. How does resume in compute pool operate? I'm going to show you that in a moment, okay? So I will be showing that in a moment. And then the second one is, streaming communications. Can we use coroutines for the streaming? So I actually did use coroutines for the streaming, but I used them very trivially. I will show you that as well. So somebody had their hand up, but they disappeared. So I'm going to keep on going. Back to transfer, okay. Transfers, the idea of transfer and resuming the coroutine on another thread brought me to my next aha moment for coroutines, for coroutine superpowers. When you go to the introduction to coroutines blogs or talks, the first thing they say is coroutines are like subroutines, and in C++ we call subroutines functions, right? So coroutines are like functions that can be resumed and suspended. And so I'm thinking, okay, great, you know, that's great. Coroutines are functions that can be resumed and suspended. That's nice. But what that doesn't tell you is what the real superpower is, and that is that coroutines exist independently of a thread and a stack. And that was something that I did not understand at first from watching the introductory talks and reading the introductory blogs. And only later did I understand. And once I understood that, my understanding of coroutines and my life became much easier, because things that were looking mysterious and ununderstandable to me suddenly became comprehensible. So what do I mean? I mean that coroutines, when you have a function, right? How does a function work? This is something everybody probably knows, should know, I hope. And that is, you put the arguments onto the stack, you put the return address onto the stack, you jump into the function, you do your work, you put your local variables into the stack, right? At the end, you destroy your local variables with their destructors, you pop them off the stack, then you put your result into some register or onto the stack possibly, and then you jump back to the return address that you popped onto your stack, pushed onto your stack in the beginning, you pop it, and you're back to where you started. The stack is exactly the way it is. And the beauty of the stack, of course, is that we can nest call. This is computer science 101, we all know that. The coroutine, however, does something completely different. It doesn't live on the stack. The point is that a function cannot be moved to another thread, because every thread has its own stack. And so you cannot grab the function out of the stack, rip it out of there, and put it onto another stack, because it doesn't work that way. It makes a mess. So therefore, once you have to realize that, in fact, the coroutine is a different beast. It exists, it has its own world, and it has its own context. And that's the beauty of it. So the coroutine can run anywhere. It can run on any other thread. It can run in another executor. It can run on another machine theoretically. And that is what Eric's talk was all about, is how the standard library will be supporting this in the future, to add cancellation capabilities, to add various algorithms to work with these. And it's really, really cool. So that was my big first aha moment that I want to give to you, is that coroutines are not like functions. They are their own little thing. And it's not just a function that they can be suspended and resumed, okay? We have a question here. Given that a coroutine is not a function, and without a stack, how can you debug the coroutine, because there's no stack frame? Yes, remember when I said I went into a world of pain? This was one of the reasons I was in pain, because the debugger was not happy. Yeah. You got it right. Debugging the coroutines was tricky. The debugger was not quite there. This will change, of course, with time. Debuggers will get better, but that was one of the big causes of my pain. So again, this goes back to, well, don't use coroutines if you don't really have to. They're great to explore, and you can do things with them, but expect pain. This is one of the pains. So great question. Thank you. So, we can start on one thread and end on another. And the really cool part about doing this transfer is that you don't need to do any synchronization. This just happens for you automatically. And that is, to me, the beauty of the coroutine, the superpower of the coroutine. You just do it, and you don't have to worry about it. The compiler does it all for you. And to me, that's the C++ dream, right? I write stuff and the compiler does magic, and it just works. When it compiles, it works. And that's the superpower. Okay, so that's what I wanted to talk to you about. I'm not going to talk about symmetric transfer. That's another thing. So we had the question, how does resume and compute pull work? It's actually very, very simple. So I basically wrote an awaiter. This is the awaiter interface. It implements these three functions. Await ready returns false because we always want to suspend the coroutine. So returning false makes sure that the coroutine will be suspended. Await suspend is called after the coroutine is suspended and gives us the coroutine handle. And then it's our responsibility to resume it somehow. Okay. And all I do is I put it into my thread pool and I call execute on a lambda that takes the handle as a parameter and calls resume on it. So I'm calling resume on another thread, and that's all you have to do to switch the coroutine to a new thread. How cool is that? Okay. And now because all this resumer does is resumes, it doesn't do anything, there's no result, and so I don't return anything from await resume. Now, this doesn't have to be a thread pool. This could be a STD thread, an STDJ thread. I think you can do STD async. I don't use STD async in these much, so I'm not sure, but I think I saw somebody doing that. You don't, of course, have to resume this coroutine. You can resume another coroutine, and that's transfer, a symmetric transfer, but that's you're going to have to get that co-return handle somehow, if you're going to do that. Okay, so this is how it works. Hopefully you understand this. And we have a question here. Is coroutine handle passed by value? Yes, it is. The handle is cheap and it's passed by value. There's probably a pointer in there secretly, but you can pass it by value. That's not a problem. You don't have to worry about references. It's not a heavyweight object. Okay. So great. This is how we resume in the compute pool. Okay. Let's go on. So again, what am I doing? When I asked you guys what can we do, you guys suggested that I can read the I/O in a coroutine, and that's a very good suggestion. I'm going to leave that for last because there were complications. All right. We talked about reading the compute on the data received from the I/O, and I just showed you how I did that in another thread. Okay. Do you see another place where I can use coroutines here? Anybody? Okay, I'm not getting answers, so I will tell you the answer myself. And what am I doing with the I/O? I'm transforming unstructured file records into DNA reads, and I'm extracting the data from these file reads, and I'm doing it one at a time, okay? Dietmar, to your question, this is why I was not able to, in fact, use multiple threads. That's not strictly true. I actually started doing that work, but it was very difficult, and this makes the program a lot more complex. But the data essentially had to be read sequentially. But what I could do is I could use a generator to do this, okay? And I don't need to use a coroutine here, but I thought, well, here's my chance to actually write a generator. Again, when you go look at DuckDuckGo on C++ coroutines in your search engine, you're going to get all those results which show you really trivial generators. If I wanted to write a generator that counts the integers that is a Yoda, I saw so many examples of this. One brave guy actually gave me the squares, which was really cool, 1, 4, 9, 16. But I wanted to write a generator, if I had a chance, it does something interesting. And here was my chance. So I realized that my I/O was sequential and I'm getting it one at a time, and that's perfect for a coroutine. It doesn't really help me with the latency, but it does give me practice with a coroutine. So I want to show you that because it's the next simplest coroutine that I did. And again, I'm going to live by what I said, write the coroutine first. So at this point, I already learned that lesson. So here's my coroutine, okay? The coroutine returns a FASTQ generator, okay? It takes a path and it opens a stream, and then it walks the stream, and instead of doing the computation, it co-yields the read, all right? The read gets basically read in the second line here, and it's co-yield. And co-yield, of course, is one of our magic coroutine keywords. And what does co-yield does? Co-yield takes the value that's here in the expression here, and essentially gives you a chance to stash that into the promise, into the coroutine promise. And the promise, of course, is part of the boilerplate that we have to do. But this is the coroutine, and you'll notice that this is basically very, very similar to what the original loop was. The only thing I changed was instead of a return, I'm doing a co-yield. And so with that in mind, hopefully you all understand what this coroutine is doing. By the way, the co-yield will suspend the coroutine. So the moment that I get a read, I am going to suspend the coroutine. And then if I want to get the next value, I resume it, and that will do the go through the loop again, and it will grab the next value. I can do this lazily, or I can do it greedily, right? So I can do it lazily by suspending immediately and waiting for a resume to get the next value, or I can do it greedily, and the moment I get the value, go and get the next one, okay? Okay, Dietmar is saying that I could get a failed get line. Yes, you're right, and I also did some work with error checking and exceptions, but I only have an hour to talk, and so I'm running out of time, and I'm sorry I won't be going into that at all, but that's a very good point. Get line can fail, and I'm using the result. Dietmar is 100% correct, so thank you for that. So let's move on. And now that I've written my coroutine, I said the next step is to do the boilerplate. I am not going to go over the boilerplate, okay? This is what the other talks are for, but I will show it to you very quickly and discuss it very quickly. So here it is, get ready. I delete the copy constructor and the copy assignment operator, and I implement the move constructor and move assignment operator. Okay, I'm not going to talk about that. I create a destructor, and the destructor destroys the coroutine frame. The coroutine handle refers to the coroutine frame, which is different than the generator itself. Remember, the coroutine returns the generator. Okay, and the generator will be used to generate the next read in the series. Okay, but the coroutine frame is in fact where what is replacing the stack. What used to be the stack is now in the coroutine frame, and that's referred to by the handle, and that's what I'm going to destroy. Of course, the generator is going to store a copy to the handle, and it gets it has this private constructor, the secret constructor, which the compiler is going to call for me, and it's going to provide me the handle that way. And when it constructs the coroutine, so it constructs the constructs the generator. It constructs the generator from the coroutine, and this is another beauty here. I don't have to worry about that. The compiler does this for me. And what the destructor here is doing is it ties the lifetime of the generator to the coroutine, and this provides you with a bunch of advantages. For one thing, it tells the compiler that I can destroy these things together, and that is a chance for optimization. The other thing is it puts some RAII into the system and prevents you from leaking the coroutine. You don't have to do this. There are situations where you don't want to do this, but this is the simplest thing to do, and this is what I do. All right, moving on. I don't want to talk about the boilerplate a lot. The next thing I did was whoops, I went backwards here. How did that happen? Sorry about that. The next thing I did was I created the promise type, okay? And again, this is, if you don't know what a promise type is, I'm going to have to send you to a introductory talk, okay? But the important thing in the promise type is that I'm storing the read, the value that I'm getting out of it, and that I have this function called yield value, and the yield value will be called by the co-yield keyword. And remember, I'm moving the value into it, and all I'm doing there is I'm moving it into this member variable in the promise type. So this is what's happening. It's going into the promise type, okay? Again, I don't want to talk about these details. Then I have move next, which returns a bool, which essentially resumes the coroutine if it can, okay? Which will go and get the next value and tell me if it can or not. If the stream ends for whatever reason, and because it hit EOF and I fall out of the loop, then move next will return false, and I know I'm done, okay? And then finally, current value is going to move the value out of the read, and which is in the promise, and give it to the caller. I am using a move here, move semantics, and which means that I am not only moving the value in the promise, I'm also moving ownership of it out of the promise, okay? And this is actually important for what I'm doing, but you don't have to do it this way. You can also return you can keep the ownership inside the promise, and of course, return a reference or a copy, but then you have to make sure that you are keeping your generator alive while you're using that reference. Generally, that is not a problem. Okay, this is more boilerplate. And finally, I have this boilerplate bonus slide, which I don't expect you to read, but this is basically an iterator that allowed me to use the generator with range for loops, with STD algorithms. I basically put a bunch of reads from the file into a vector, and that was really cool. I wish I had this when I wrote all this code, but this is just to show off. I didn't actually use this. Okay, so I'm not going to talk about it. So that is the example of using the code keywords in the body. I wrote the generator code first, and then I wrote the boilerplate, and that was the correct thing to do. And I tried to do it the other way. That ended badly. Was the major learning. Plus, again, the idea that the coroutine is not a function, but it's an independent thing. So now let's talk about the next big aha moment I had, which is that the work goes into the coroutine body. Is the example code available online with the sample input file? Not exactly. I do expect to put it into my GitHub, and I don't think I have it on the slide. Please remind me at the end, and I will tell you where it's going to go eventually. All right, and I'll explain why at the end of the talk. But the code is here in the slides mostly, but yes, I do intend to check in the code to GitHub. All right, the next thing is the work goes in the coroutine body. And what do I mean by that? Well, you again may say, well, gee, Cheinan, that's obvious. Why are you even saying that? This is obvious. It was not obvious to me. I come from the school where you have this pattern where you are putting jobs into a queue, right? And then you have worker threads, and they pull the jobs from the queue and they do them. And the way I used to do this was that I would have a base class, and I would inherit it, and I would have some sort of virtual method called do, which I would override, and then I could execute something, and I might have an undo, and that's the command pattern from the Gang of Four book. This is old style stuff. We all know how to do this. There's nothing new there. Okay, and so when I came to coroutines, remember the coroutine returns a class that people are calling the task or the job. Okay. James McNally calls it the resumer, which I think is a better name, actually, but or a resume object, I think. But anyway, task or job is also good. And I expected to put the actual work that was happening into the job. And this confused me for about a day. And I tried to do it, and it didn't work, of course, and didn't work. And finally, I got the realization. The work that needs to be done in the coroutine goes into the coroutine body itself. Now, if you're doing async work that notifies, that can possibly go in the awaiter, and then you have a notification call that will resume the coroutine and possibly go on another thread, and then you can co-return the value. But in fact, as I told you, it turns out that my I/O was synchronous here. Now, I thought at that point about switching the problem and doing something asynchronous, but I had so many good learnings from this. I thought this was enough, and I have enough for a talk here. And so now I have a third talk that I could give, and I stuck with it. So the big learning that I got here was that the needed synchronous work goes in the coroutine body. And again, this is another coroutine superpower, because think about it. The way I described how to do that job object, you had to write the actual work in this one object, and it gets called in a completely different place, and it was terrible, and maintaining it was a big pain, and it was very not fun. Okay, what the coroutine does is it gives you one place to put the job work and to execute, to do it, and then you can execute it in many other places. And so what it's doing is it's letting you centralize that work in one place. And this was another aha thing that I had. Is like, oh, you just put the stuff in the coroutine. And this goes back to my previous point, which was write the coroutine body first. That's because the coroutine body is what does the work. And I hope this is obvious to you. It wasn't obvious to me, but if it wasn't, welcome to my world, and hopefully that helps you understand coroutines a little better. So let's talk about the I/O now. Antonio is asking, somewhat similar, I guess, to adding tasks with inline lambdas for the actual work. I'm not sure what you mean exactly. I'm not sure what you mean. If you want to rephrase the question and be a little more specific, I can try to answer it. I believe you can do a coroutine in a Lambda. I think I saw somebody doing that. I haven't tried that. You know, as I said, I had so much pain from coroutines. I didn't want to make things even more complicated. So the answer, let me answer that with I'm not sure. I don't know. Okay. So what happened here in the coroutine? Here's my IO, which I gave up and decided to make it synchronous. Okay. Notice I added an is canceled atomic Boolean, which I'm not showing here. Okay. And that checks if the coroutine's finished. All right. I'm checking if there's more data in the generator. Remember, this returns a bool. And if there is, I go call current value, which returns not just the read itself, but ownership of the read. And that's why I call read empty on the next line. I check if the read is empty and I co-return a 0. That is, I have no compute work to do in that case. Why do I have to do this? Because I had the great, and when I say great, I mean that ironically, idea of doing this. Remember, we talked about I could put the IO in a coroutine. Okay, and so I did something like this, except that I uncommented this line, essentially, and I put the IO into its own thread. Now, because the IO had to be sequential, I kept it in one thread. Dietmar points out that I could do it in multiple threads, and yes, there's a way to do that, even though the records are unstructured, but it's very, very difficult, and it just made the problem too complex. So I stuck to the sequential thing, but I still thought I could put it into its own thread. Well, what happened then? This turned out to be a really bad thing, okay? Does anybody see what the problem is in putting the IO on its own thread in this way? What bad thing would happen if I uncomment this line that's emphasized here? Anybody want to try and answer? We have Keith hand up. Oh, Keith, you disappeared. Oh, there you go. Go ahead. You're muted. There you go.
Why don't you finish your thought, because it's a bit of an unrelated question.
Okay.
Sorry, you just asked that question, and it was a different question. So
okay,
why
gotcha.
can't we do this? You were saying.
Yeah. Do you want to make a suggestion?
No, I had a different question.
Okay.
Sorry.
All right. Let me finish my thought, and I'll get back to you. Anybody else? Okay, we got somebody else. Bogado. There you go. You're on, Bogado, you're on the air. I always wanted to say that.
Hi. Would be because the read generator could be destroyed inside before it resumes?
No, because in fact, you don't see this. I chopped this off because of the slide limitation, but this ... is the coroutine is getting the read generator by reference. So the read generator's lifetime is longer than the coroutine.
Oh, okay.
Okay, but yeah, good idea. Thank you. Anyone else? Okay, I'll answer my own question then, and then I'll get to you, Keith, if you keep your hand up. You don't have to. I see you there. Okay, so what happened was, let's think about it. If we are resuming the IO in an IO thread, remember the IO is slow, okay? And so it takes time to read that. What's going to happen? The resume an IO thread, remember, suspends the coroutine, and then it's going to execute the resume on a different thread, on the IO thread in this case, all right? But what happens to the suspended coroutine? It returns to the caller, right? So we return to the caller of the coroutine, which is then going to loop, get another read, and do another compute. But, okay, the loop is much, much faster than the IO is going to be. And so what's going to happen is we're going to create another coroutine that's going to try to read the same value out of the generator. And in fact, I was able to generate 5,000 coroutines for every read. Yes, Keith, we hear you, by the way.
Oh,
You're
I'm
welcome
sorry.
to react. That's okay. 5,000 coroutines, and because I passed, and then first what happened was I didn't have the smooth semantics, and so every coroutine was now returning a result, and I was summing them all out, and of course I was getting the wrong answer. Then I added the if read empty, and that took care of that, but I still had these spurious coroutines there. and that was just terrible. All right, and so that is why I ended up making the synchronous. I commented this out, and all these spurious coroutines went away. I was creating coroutines which were doing nothing because the I/O was so slow. And so could I have synchronized this and done this a different way and queued it up? Absolutely. And I could have written a coroutine that queued things up, and that would be the next step. But again, I'm running out of time here. And so I need to finish this in 10 minutes, and I won't have time to go into that. So Keith, go ahead and ask your question now.
You can hear me, right?
Yes.
Okay, so it's a bit of an aside, and thank you for that short comment there. That was great. Can you just give us 30 seconds on the structure of your data? You know, you're talking about reading lines. I initially thought that these files that are hundreds of gigabytes long were one continuous string. I mean, what do your data look like?
You know, I'm sorry, I don't have a slide with that, but that's a good question. Thank you. The files are made of ASCII strings with new lines, separated by new lines. They're about, my reads were 150 characters long, okay? So the length, I don't want to go into the details, but it's all the other lines, one line has the same length and the other two lines are much shorter, okay? So it's basically name of the read, it's the DNA read, the strings, AGCT, 150 times, new line, and then it's a plus sign, new line, and then it's what we call the quality values, which is a bunch of other strings, okay? But that's it, so it's new line separated data. And then they're in 4-line groups, and I want the second line from every group, okay? I hope that answers your question.
And
yeah.
Can you still hear me or no?
Yeah.
And so I must say then that if you've got these broken lines, if the data are essentially continuous, wouldn't you perhaps miss string finds across the different lines? Did you consider
I only want to search on the second line. I'm not interested in the other two lines and the other 3 lines in the record.
No, I'm talking about the lines before and the lines after. If these are a continuous stream of sequences or data,
right?
You know,
but that's what the generator is doing. The generator is feeding me one read at a time. It's filtering out all the excess stuff and giving me one read at a time. That's what the generator is doing.
But it's giving you a read of one line at a time, correct?
No, it's giving me one read. It's only giving me the second line. Okay.
Okay. Okay, I understand you're short on time. Thank you. Thank you.
Yeah, I am short on time. So forgive me for moving on. All right, let's, I have to move on. All right, where was I? Okay, so. So the point is that the work itself goes into the coroutine body, and I'm going to skip this slide. I'm going to skip ahead a bit, and that is the second superpower of coroutines that I discovered basically. So I am very short on time, so I'm going to pretty much wrap it up now. The next thing I wanted to say, and I'll go through these points quickly, are be careful with object lifetime and ownership. Coroutines are not exactly RAII objects. There are tricky things to do this. And here are some of the things I learned about coroutines that you want to be aware of, okay? If you probably want to always return suspend always from your final suspend if you want to get the result from the coroutine. Because if you do not suspend always in your final suspend and you suspend never, the moment that final suspend is finished, your coroutine frame is destroyed, and then you've lost your promise and you've lost everything in it. I found this out the hard way. Fortunately, this was also documented and it was not too hard to solve, but you probably want to suspend always from your final suspend. There are times when you don't want to do this, and there are coroutines, of course, that don't return anything, and maybe you can just destroy them. And remember, my destructor checked that the handle was good before destroying it, so that wasn't a problem either. But this is a nice guideline to have. And remember that once final suspend is done, you're done with the coroutine, okay? The second thing I learned the hard way is references to coroutine internals are valid for the life of the coroutine. I think this is obvious, But there was one tricky part here, and that is that the coroutine had to define start point as well as end point. Okay, so be sure not to look at things too early either. All right, I don't have time to elaborate, unfortunately, about my experience. I'm really out of time. And then the last thing I want to say is final suspend is final. You cannot resume a coroutine that's in final suspend. I tried to, it crashed. Thank God it crashed because it's undefined behavior, and we all know what undefined behavior means. So let's conclude the talk, okay? Again, consider not using coroutines if you can. They're tough, all right? It's like writing in assembly language. And as somebody who's actually written assembly language way back in my day, it can be fun, and it has its own beauty and fun and interest. So do use coroutines if you want, but expect difficulty and expect pain, okay? If you want, do wait for the next standard. And of course, experimental, I assume STD experimental libraries will be coming out soon. In fact, I think Jeff Garland has to talk about on Friday what's coming in the C++23 standard library, okay? Coroutines are not subroutines. That was the big learning. If you didn't quite get this in my talk, ping me during the week or email me afterwards. I'll be glad to try and elaborate on this more. This is a very important point, okay? Then plan out the use of the coroutines, and the work goes in the coroutine body. This is what we just covered. I won't belabor that. But then what I wanted to say, and I didn't have it all time to do, unfortunately, you still will have to write some sort of manager or queue. And this is the unfortunate thing, because that was at least half the work, all right? And if you went to Gor's talk, Gor shows you his queue. He has what he calls a throttler. Francesco, in his talk, does an even better job. He shows you his executor, and it's really nice. And what you're going to see is that this executor has to have knowledge into the coroutine internals. It's intrusive. This is not a simple thing. This is why you really, really want to wait for the C++23 executors to come, because they will take that pain away. This is a one line on my final slide, but this was the majority of work right here. And this is why I don't have my code checked in at this point, because mine is ugly. I saw Francesco's and I was like, oh God, I need to redo this completely. So, and then the final thing I want to say is, because coroutines are so tricky, the bugs I found were the sort of things where they worked perfectly in debug and crashed in release. And then when I would add print statements to try and understand what was going on, it started working again. These are the worst kinds of bugs, you know? And so make sure your coroutine is working correctly. Have unit tests to test it. In my case, I did have a unit test, and make sure everything is working correctly before you start optimizing. And in my case, that's why I have all those spurious coroutines in the IO thread, because I got it working first. Then I discovered, oh my God, I have millions of coroutines that are processing 1,000 lines. And I started optimizing and chopping those things away. But do that. And I have time, I think, now for 2 questions. Of course, we will be in Gathertown for a bit after this, so you can follow up with questions then. But I think I have time maybe for 1 or 2 questions now. I have 90 seconds. So please, any questions before we close? That will be recorded forever on YouTube. Okay, friendly reminder to put the code on GitHub. So my name is Cheinan. It's on the slide here. Okay, so just go to github.com/Cheinan, and I will have a CPP 2021 eventually there, because I want to redo my queue, and that's why, in fact, I don't have anything in there, but I will put it in github.com/Cheinan. Look for it there. That's how Cheinan is spelled. Okay, and apologies for not posting that in the slide. All right, we have, what kind of speed up did you see? Well, in fact, it turns out, Robert asks, it turns out that the threaded consumer producer ran faster. Adrian asks, any performance numbers with or without coroutines? Yes, I was able to process 5 million reads with the one threaded routine in about 3.5 seconds. The coroutine did about the same. The multi-threaded, I was able to cut that down to about 1 second. That's why the coroutine actually was not the winner here, and I need to work on my queue to get that better. Why do you recommend, Matthew asks, why do you recommend waiting until C++23 to really use coroutines? I thought that's what the talk was all about. because all of the pain and boilerplate and debugger issues will not hopefully be there and will be handled by the standard library. You won't, and Adrienne answers that very nicely for me there too. Okay, so I think I'm out of time officially. Track host, can I keep on answering questions, or should we move together, Tom?
If there are more questions, you are free to answer them.
Okay, are there any more questions here? I think I got everything. If coroutines is not faster, why use it? That's the great question. I take you back to my first conclusion, right? Consider not using coroutines, okay? Coroutines very probably can be made to be faster in this situation, but the amount of work you have to do is just incredible because you're like writing an assembly language. So that's why, but that is my first conclusion. Consider not using coroutines. And in this situation, I probably wouldn't use coroutines. Okay, coroutine, but this is always the case with new features in C++, right? You go to a CppCon talk, you see a new feature, you're thinking, oh, I need to use this, and you use it, and of course, it's not as simple as you think it was. And this is what coroutines. Coroutines are beautiful because they're going to compose. Coroutines are beautiful because they're going to work with the structured concurrency of the executor library that Eric Niebler proposed. Stephen Downey showed a very nice illustration of coroutines that can be used to do functional programming with abstract algebra ideas. This is, to me, the beauty of coroutines. Plus, there's superpowers that I showed that you can move them from thread to thread, that you do the work in the coroutine and you don't have to hide it in boilerplate code. These are what coroutines are good for, but we're in early days. That's why I'm saying wait for the library, because yes, can you do it today? Absolutely. But you're basically, it's like writing your program in assembly language. Can you do it? Sure. But wouldn't you rather write it in C++ and save yourself all the trouble? That's where coroutines are the real winners. So I hope I answered that question. I think we're all done with questions. I don't see any more. So I want to thank you very much for your attendance, and hopefully you've learned something from this talk. I certainly did. Feel free to contact me afterwards and during the conference. I'm around mostly on Discord. But I'm going to try and be in GatherTown a little more now that my talk is over. Thank you very much, and have a good afternoon or a good night wherever you may be, or good morning.